The potential impacts of climate change in Estonia. Estonia is a small country in northeastern Europe, bordering Russia and Latvia. Estonia's many inlets and islands give it a surprisingly long coastline and an area of 45,000 kilometres squared. Historically, Estonia formed part of the USSR, but has had independence since 1991. As you can see from the map, many of Estonia's financial centres are on the coast. Impacts of climate change on Estonia. A longer growing season will benefit Estonia's agricultural sector, favouring both traditional crops such as potatoes, barley and hay, as well as potentially allowing new crops to be grown such as oranges, olives and wheat. A longer growing season will also favour forests and woodlands, as well as increased levels of atmospheric CO2, providing the necessary tools for growth. Tourism may also benefit from climate change as the tourist season is extended. Estonia already has a thriving tourism sector, so if companies are adaptable, then scenes such as this could soon be replaced with ones like this. In a warming climate, it is reasonable to expect that heating requirements will be lowered. This will save people money and have positive environmental effects if less trees are cut down and less peat removed for burning. However, Estonia also has vast deposits of natural shale gas, which it exports to Russia. This industry provides millions in income and provides thousands of people with jobs. If other countries are also expected to experience climate warming, then it is realistic to expect a partial collapse in these industries. At present, the Baltic Sea partially freezes for several months of the year. This includes Estonia's capital city, Tallinn. Estonia currently has 2 ice-breaking vessels, costing millions of euros each, and soon their expensive upkeep may longer be required. At the current rate of warming, it is expected that Tallinn's ports will be ice-free all year round by 2050. This will increase potential trade via shipping routes as well as allowing tourism cruises to access the city all year round. On the flip side, however, sea ice forms a barrier between Estonia's coastline and the Baltic Sea, protecting it from storms and aggressive wave action during the winter months. Species range shifts. Estonia is particularly species rich as it sits on the boundary between western and eastern Paleoarctic regions, as well as maritime and continental zones. One success story is the sooty copper butterfly, which used to be incredibly rare in Estonia, but is now relatively common. The species has extended its range northward as the climate warms. Butterfly and wildlife tourism are pre-existing industries in Estonia, so an influx of new species may be beneficial for these sectors. Estonia also has a history of being the last refuge for now extinct species, including the woolly mammoth. Overall, warmer winters and cooler summers will lead to less seasonal extremes, which will help agriculture and tourism. Negative impacts of climate change in Estonia. As the Estonian coastline is 3,800 kilometres long, it is particularly vulnerable to sea level rise. Almost 2/3 of Estonia's territory lies less than 50 metres above sea level. Beach erosion will have negative impacts for tourism and could destroy harbours. However, Estonia is experiencing isostatic land uplift after the retreat of the last ice age, and so sea level rise may be compensated for in this way. Increased precipitation as well as increased storm surge frequency and intensity are predicted for Estonia and the Baltic Sea. This area is very complex meteorologically, so it is not certain exactly how Estonia will be affected. However, it is anticipated that more events such as Windstorm Irwin, which hit Estonia in 2005, can be expected. This led to millions of trees being prematurely felled across northern Europe, devastating the timber trade. Estonia is very diverse geologically, though large parts of the coastline are made up of soft limestone and sandstone cliffs. These are easily eroded in storm events, and a rise in sea level will exacerbate this. Also of importance is the presence of the Sillamäe metal and chemical production plant, which produced enriched uranium for the Soviet Union during the Cold War. Overall, 12 million tonnes of radioactive waste was produced at the plant over its 50 years in operation. Waste from the facility is stored in a tailings pond, which is just 30 metres from the Baltic Sea. Severe erosion here could have catastrophic consequences, and the cost of defending the site will only increase. Habitat destruction and degradation. Many of Estonia's ecosystems are also at risk due to climate change, and in particular sea level rise. These include coastal meadows, flooded meadows, and reed beds. Among the areas likely to be affected are the Kasari River and the Metsala reed bed, which are some of the biggest and most important breeding grounds for birds in northern Europe. To lose these would be a real blow to Estonia's conservation efforts. Similarly, species range shifts might also negatively affect Estonia, with the introduction of invasive species or the loss of suitable habitat. Estonia is home to 15% of Europe's plant and animal species, which equates to 1% of the world's total species. Many of these species are at the very edge of their ranges, and some are included in the IUCN Red List, such as the European mink, the Siberian flying squirrel, and the sand lizard. This is true of both plant and animal species. Pärnu is the most important of Estonia's fishing ports, though aquaculture around Estonia's many lakes is also important commercially. Around 55,252 tonnes of fish are caught per year, with a landing value of around €15.3 million. The main species landed are sprat and Baltic herring. Needless to say, Estonia is highly dependent on its fishing industry. Climate change in northern Europe is expected to affect both the temperature and the salinity of the Baltic, making it warmer and fresher. It is therefore likely that marine species, such as the sprat and herring, will withdraw from the Baltic Sea. However, this may be compensated for by the likely increase in freshwater species. This will also have important cultural repercussions, as Estonian society has developed around these fisheries. This is demonstrated by Estonia's national dish, which is a type of fish stew. Increased precipitation will also be widely felt throughout Estonia, leading to increased soil erosion, lowered salinity of the Baltic, and increased river flow. These will all have drastic ecological effects. Sediment levels in the Baltic will increase as more soil particles are eroded inland and washed out to sea, impacting visibility and primary productivity negatively. Similarly, increased nutrients from continental runoff may cause instances of eutrophication and lead to algal blooms. Heatwave-related health impacts. As with the rest of Europe, increased mortality rates have been observed in Estonia with relation to heat waves, the frequency of which are likely to increase as climate change progresses. Climate refugees. Climate change is already displacing people through flooding and drought, and as levels of CO2 in the atmosphere continue to increase, it is likely that more people will find themselves displaced. Coupled with the likely increase in conflict due to increasingly scarce resources, the number of climate refugees could be in excess of 30 million people from Bangladesh alone. It is probable that these people will look towards environmentally favourable locations, such as Estonia, to relocate to. This may put pressure on existing services and infrastructure, but it will also provide a new pool of labour for existing industries to access. In conclusion then, the main benefits that climate change poses for Estonia are in the form of agriculture and tourism, whilst the biggest threats are in relation to coastal erosion, flooding, fisheries, industries, and climate refugees.
Where can I find